This lesson we're going to be looking at the ambiguous cases of law of sines. So whenever you have two sides and a non-included angle given, it doesn't necessarily define a unique triangle. As in the figure, if you have the measure of angle A and you're given the measure of sides A and B, then side A can either be as it is in the solid segment, or A could be the dashed segment in the figure. So in this case, the result will be either no triangle, or exactly one triangle, or in the case of the previous slide, you could get two triangles that are formed. Now, if the non-included angle, if it's less than 90 degrees, then first we want to find out what the measure of the other side is times sine of the angle A. If that quantity is less than lowercase a, if A is less than that quantity, then we'll end up with no solution. If A is equal to that quantity, then we'll get one solution. If A is greater than that quantity, then we'll get two solutions. Now, if the non-included angle is less than 90 and A is greater than or equal to B, then we'll get just one solution. If A is less than or equal to B, then we'll get no solution. If A is greater than B, we will get one solution. And that's if angle A is greater than or equal to 90. All right, so in this example, we are given the measure of one angle, and that angle is the non-included angle, and we're given two sides. Two sides in the non-included angle. The measure of that angle is less than 90. So we want to find out what the measure of the side that is not opposite that angle, which is 11, times sine of the angle A, which is 37. And that gives us approximately 6.6. And since 4, the side opposite angle A, since that is less than 11 sine 37, then that tells us that there's going to not be, this is not going to be a triangle. Again, we have an angle and the measure of two sides. That angle is not the included angle. It is, in this case, greater than 90. And A is less than B. 30 is less than 36. So that tells us that there will be one solution. So we just use the law of sines. 36, which is the measure of B, over sine of B, sine of 96, equals A, which is 30, over sine of A. And we're trying to solve for A, angle A. Cross multiply, then divide both sides by 36, and then take the sine inverse of that quantity, and we'll get approximately 56. Now that we know two of the three angle measures, we can add those two angles up, subtract that quantity from 180, and we get 28 for the measure of angle C. And then to find the measure of C, we're going to use that same ratio from the first proportion, 36 over sine of 96, and then set that equal to lowercase c over sine of angle C. We just determined the sine of angle C was 28, so sine of 28. Cross multiply, solve for C. So to solve for C, we need to divide both sides by sine of 96. We get approximately 17 for the measure of C. All right, now we want to solve this triangle. We're going to start by taking the measure of the angle that's given, which is 90. the measure of the angle is 48, which is less than 90. So we want to find out what the product is for the side that is not opposite angle Q, which would be 19, times the sine of angle Q. That quantity is approximately 14. And since 18 is greater than 14, that tells us that there's going to be two solutions. So we're going to start by setting up our proportion as Q over sine of Q, and that's going to equal P over sine of P. Cross multiply, and then to solve for P, we're going to have to divide both sides by 18 and then take the sine inverse of that quantity, and we'll get approximately 51.7. And then now that we know two of those angle measures, we can add them up and subtract that quantity from 180 to get the third angle, which is going to be approximately 128.3. Actually, since we have two solutions, there's going to be two possible values for angle P. So angle P, when we did the calculation, we got 51.7. And so the other possibility for angle P is going to be, the other possible angle is going to be supplementary to the angle P measure that we just found. So we're going to subtract that 51.7 from 180 to get the other possible measure of angle P, which is 128.3. And then now we're going to add those two angles up and subtract them from 180. So 51.7 plus 48 subtracted from 180 gives us that 80.3. And we can add the 48 and the 128.3. Add those two up, subtract from 180, and we get 3.7. Now, whenever R is 80.3, we can solve for the corresponding side, the side that's opposite angle R, by doing 18 over sine of 48 equals R over sine of R. That will give us a approximate measure of 23.9. And if we were to use the measure 3.7 for angle R, we could set up a similar proportion. 18 over sine of 48 equals R over sine of R. In this case, R is 3.7. And that would give us a measure for side R of approximately 1.6.